All right, our objective for today, I can solve and graph multi-step one-variable equations. Read together. One, two, three. I can solve and graph multi-step one-variable equations. Now, notice on your Cornell notes, it's a little bit different. I just wrote, I can solve and graph one-variable equations. Okay? Because we're going to focus on one-variable equations, which is our main concept for today, and probably this week and half of next week. Now, today's going to go a little fast because we're going to start with the simple ones and then move on to the funner ones. But this is going to be more like a refresher for you guys from what you guys did last year. But I want to clarify some things before we move on. Okay? So here we go. So one variable equations, what are they? It says mathematical statements where two expressions are equal to each other and contain one unknown variable. And I gave you guys these examples, yes? However, from the definition, I want you to underline a couple of things which will make it easier to remember the definition. One variable equations are two expressions equal to each other. Isn't that a little bit easier to remember? Two expressions equal to each other. However, what is the last requirement? Only what? One variable. So far so good? Once again, one variable equations are what? Two expressions equal to each other, one variable. Now watch. I'm going to zoom in so you guys can see what I'm talking about in regards to two expressions. I'm going to start with this one. If I was to cover this up, isn't this an expression? It's a algebraic expression, yes? We covered that last week. But if I cover the other side, oh my goodness. If I cover this side, isn't this a numeric or numerical expression, yes? All right, therefore, if that's true, that means that we have an expression equal to another expression. So according to the definition, here it goes again, two expressions equal to each other. Do we have two expressions equal to each other? Yes. One variable. Do you only see one variable in this equation? Yes. Let's go to the next one. Expression equal to each other, one variable. Yes. Yes, 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 and yes. Okay, let me give you some non-examples. Copy these. We have 4x plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, and 4x plus 6 equals negative 2y. Copy those, and then we'll talk about why those are not one variable equations. All right, talk it over with your neighbor. Let me know why each of these is not a one variable equation. Go.
And the one
All right, let's see. 3, this one. Why is this not a one variable equation? Does it have an equal sign? So what would you call this one? An expression. Label that expression. That is correct. That's why it's not a one variable equation. The next one. Why is this one not a one variable equation? Julian.
because there's multiple, because there can be a multiple answers. Like, for example, you can just put whatever answer you want on there, and it should equal to what it says. For example, 4 minus 8, that's negative 4. That's the reciprocal. And 8 minus 8, that's negative, which is another 8.
Good. And if you were to say it in one or two words, why is this one not a one variable equation?
Because there isn't an exact answer.
Okay. Haley-Ann. They're comparing. Who notices that it has a specific symbol here? This one is called an inequality. Inequality. Therefore, look up please. If all these are one variable equations, what would we call this one? Tell your neighbor, what would we call this one? Jason, go.
One variable.
That is correct. One variable inequality. All right, let's move on to this one. Let's see. Avril, why is this one not a one variable equation? Look at all these, and look at this one. Because of the exponent. Okay, that is true. Now, Avril, if we were to give it a name, think about it. We just finished with polynomials, didn't we? And we gave polynomials a name according to degree. Are we there? What would you call this because of what you pointed out? What would you call this? Very close. I'll keep the first one, which is a quadratic. Close. Now, equation, because it has an equal sign. Did you see that? All right. And the last one. Look at this one. Let's see, Brody. Why is this one not a one variable equation? Look at all these, and look at this one. Help them out, you know? Luca? It has two variables. So what would we call that? Tell your neighbor, please. Two variable equations. That is correct. Well, guess what? Let's see. And I'm going to go down the list. Look up. Are we done with expressions? Yeah, because now we are in what? Equations. We're done with expressions. We haven't covered inequalities, but we are going to cover inequalities. We are going to cover quadratic equations, and we are going to cover two variable equations. I'm just giving you a heads up as to what's coming. All right? So with that said, hashtag. Share with your neighbor a hashtag for this concept. One variable equations are what? Hashtag what? All right. Charlie, go. Bam. Equations. Another one. Ryan. No inequalities. Pablo. One variable. Who has one more? Any more? Devin? No expressions. All right. We good? Yes? Yes, thank you. All right, good. All right, steps. I gave you the steps already. They're already written in there, but let's just look it over, and then so we can see what's going on for each step. Look at first step. Simplify each side of the equation. First of all, have we been simplifying expressions? Okay, for the past month and a half, have we been simplifying expressions? Yes, so we know how to do that. And if we know that each side of the equation is an expression, do we know how to simplify it? Yes. And it says here, start with grouping symbols and combine like terms. Okay, that's simple to remember, yes? Step 2, isolate the variable by using inverse operations. Now, some of you are like, isolate. Now, you might have friends, not you guys, but you might have friends that they've gotten referrals before, right? Of course, not you guys, your friends. And one of the boxes, it says student was isolated. Have you guys seen that in your friends' referrals? No? You're like, no, I don't have friends like that. Wow. Uh, what do you think isolate means? To separate, to leave it by itself. Well, that's why step 2 is to leave the variable by itself. Step 3, plot your solution on the real number line. Do we know what the real number line looks like? Yes, and to plot, I'm going to refresh in your memory what you saw last year. And at the end, we're going to check our solution. Okay? You're like, Mr. Q, that's a lot of words to remember. All right, let's simplify it. Circle the first word of each step. Simplify, isolate, plot, check. 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 Take over the steps.
Simplify, isolate, plot, check.
Yeah, we got this, yes? All right. So, we got that. All right. So now let's look at some of the history about equations. Look up to the screen, please. Now, who's seen movies about, let's see, gladiators and the Roman Empire? Have you guys seen some of those movies where they're wearing togas and stuff like that? Well, back then, check this out. Back then, when people would go, what we call now farmers market, when they would go out to the market, they would have this. Everybody see that? This is a scale. And of course, it had something holding it up, like right here, like a little design type of thing, like so. And then it was on top of a table and so on and so forth. Well, how does that work? Well, let's say Isaac went to the market wearing his toga. He gets there. Yeah, let me have 8 pounds of frijoles. All right. So then they would put a bag here, and then they'll start pouring frijoles in here till it reached 8 pounds. What's going to happen to this side? It's going to drop, right? Well, guess what? In order for them to know where to stop, what needs to be on this side? 8 pounds. So that's the counterweight. They need to add 8 pounds. And that's where they get where last year your teachers told you whatever you do to one side, you do to the other side. You remember that? Kind of, sort of? And it works the other way around also. Let's say Nanelle went and she wanted to buy oranges. Let me have 11 pounds of oranges. So then they place the bag on this side. There it is. We start dropping oranges in here until it fills 11 pounds. But the counterweight has to be also what? 11 pounds. Well, that's where they get equations from. Now, of course, let's say Nanelle, she went to buy the oranges, and being a mathematician, everywhere she goes, she's always thinking about math. Right now? No. So, and all of a sudden she starts walking away, and she's thinking about that scale. And all she sees or she remembers is the bar. Look up, guys. The bar and the table. And she keeps walking away and turns and looks at it. And she keeps walking away. She's almost a block away. She turns and still looking at the bar and the table. And now she's almost 2 blocks away and she's still looking at that. What does she see from 2 blocks away? Tell your name. Let's see, from far away it looks like this. Yes? And what does that look like? That is correct. So our equations, we get it from balanced scales. That's why it needs to be balanced. The bar needs to be balanced in order to be a balanced scale. Well, with that same thought, look what I'm going to do next. Watch. What's on this side? 8. What's on this side? Where was the original bar? Right there. Tell your neighbor if you see it. Does everybody see it? Okay, some of you are like, what's happening? Something's happening. I don't know. Here it is. 8 greater than 0. You guys see it? Inequality symbol. Same thing the other way. What's on this side? 11. What's on this side? 0 over the original bar. There. Therefore, 0 is less than 11. Therefore, what can we conclude? Equations have to be balanced. Inequalities are what? Not balanced. All right, good. Julian, put that away. Thank you. All right. So, lastly, before we get into solving equations, look up. Equations require a certain process. Now, if I was to take a variable and do a lot of stuff with it, I create an equation. But then to undo it, we need to know what to do to undo the equation. So let's say Isaac. Isaac goes to the mall and buys a gift for a special someone. Ooh. And he doesn't let us know what it is. So since we don't know, I'm going to label it X. Get it? Don't know, unknown. Never mind. All right. So then what would be the first thing he does in order, if he's going to give away this gift? Place it in the what? Very good. So there's the box. All right. There it is. What would be the second thing he does? There's the wrapping paper. There it is. He's going to bring this in, use some Scotch tape, and then isn't it always that when we wrap something, we have excess wrapping paper? What do? Get rid of it, right? Excess. And then, of course, he has like a ribbon. There's the ribbon. And what is he going to do with the ribbon? Put a little nice bow or something, right? So then at the end, it's going to look something like this. Let's see. And here's the bow. There it is. Everybody picture it? Yes? All right. Well, guess what? Equations are this. It's a gift that's wrapped. And to unwrap it, bam, Julian in the house. What would be the, so Isaac rings the bell. They come to the door and it's like, oh, what a nice gesture. What would be the first thing they do with that gift? Be nice. What? They keep it, all right. Next, what would be the next thing they do? Unwrap it. But what is the first thing they take off? The bow. Next, the wrapping paper. And next, the box. And at the end, they end up with whatever was inside, yes? Well, guess what? The operations to get to that X, watch. Before we get to that, to make it a gift, we used, what is it that we used last week? This, right? And what was the last step last week? Addition and subtraction, right? Well, now the opposite way is addition and subtraction, multiplication and division, and at the end we do what? See how we're going out backwards? And we're like, I kind of see it. All right, we'll see it in a little bit. All right, so lastly, where are we going? Check this out. Today we're going to cover up to right here. Tomorrow we'll cover some more multi-step equations. What does a one-step equation looks like? X plus 3 equals 7. X minus 2 equals 10. Multiplication, 2x equals 20. Division, x divided by 7 equals 30. Two-step equations is combining two different operations. I'm going to combine multiplication and subtraction. 2x minus 8 equals 28. I'm going to combine division and addition. X over 7 plus 3 equals 8. These are two-step equations. Three or more steps. Look at this one. 4x plus 8 plus 2x equals 18. Another one. 3 parentheses 4x plus 5 equals 21. These are three steps. And multi-step with variables on both sides looks like this. 4x plus 1 equals 2x plus 7. Do we have two variables on both sides? Yes. And this is where we're going. We're going in that direction. So for today, I'm going to start off with this, going to this, going to this, and we'll stop right there. So copy this one, please. Example 1A. Copy that underneath the steps. Example 1A. X plus 2 equals 25. We're going to do this one together really quick. What is the first step of our steps? It says simplify each side. Question, can I simplify this side?
Yes.
No, because it's already simplified. Can we simplify this side? No. All right. But to remember that this is a scale, I'm going to draw a line down the equal sign because that's my scale. So, next, what operation do you see here? Addition. So we're going to leave the variable by itself by using inverse operation. So what is the inverse? Subtract 2, subtract 2. And we're left with x equals, bless you, 23, Michael Jordan. Next, we're going to graph this or plot it. Here it goes. Draw your number line underneath. Put 0, dot, 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 to 23, and you plot your point on the number line. Last step, we're going to check. I'm going to write the original equation, x plus 2 equals 25. But instead of x, what am I going to substitute, everyone? 23, bring down the 2, equals 25. 23 plus 2 is 25. Is 25 equal to 25? Yes. Let's see. Simplify, isolate, plot, check. Simplified, isolate, plot, and check. We got it? Yes, Mr. Q. All right, do this next one by yourself. Example 1B. 1B. Copy that and go. All right, let's see what we got. Line down the equal sign. What operation do we have here on this side? Because we can't simplify anymore. What operation do we have? Multiplication. What is the inverse of multiplication?
Division.
So we're going to divide to leave the a by itself. But what are we going to divide by to leave a by itself? Whatever is next to it, which is -2. Whatever we do to one side, we do to the other side. -2 over -2 is 1. We're left with a equals. These are not the same sign. 14 divided by 2 is -7. And so we got that. Okay. Let's plot. 0, dot, 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 -7. Plot your point. And lastly, we're going to check. So we got -2a equals 14. And we said it's multiplication between these two, yes? -2 times -7 equals 14. This is 14 equal to 14, and that is true. For example, yeah? Last one of these simple ones. Copy this one. Example 1C. Let's see how you do. There it is. -3 equals m over 4. Copy and go. All right, check it with the neighbors. See how much they got so far. Okay, here it goes. Line down the equal sign. Where's the variable over here? Can I simplify anymore? No. But to leave the m by itself, what operation is going on this side? Division. What is the opposite of division? So I need to multiply this side by whatever's happening to this one. What is that? 4. So I need to multiply by 4. If I do that to this side, I need to multiply times 4 times the other side. We're left with negative 12 equals. Now look at this one. Whenever you multiply like this and there's division like this, all you have to do is this. Does you ever see the giant 1? You're like, oh yeah, because 4 times m is 4m over 4, and what is 4 over 4? 1. So we're left with m. Do we know how to plot? Do we know how to check? Yes? All right, let's crank it up a notch. Copy this one. This is a 2-step equation. The ones that we just did were 1 step. So this is a 2-step, so we're going to example 2Q. 12 equals 4y minus 8. We're going to do this one together. Ready? Line down the equal sign. Look at this side. Can we simplify this side? No. Can't combine anything. How about the other side? No. So that means we need to leave the y by itself. What operations are going on here? Subtraction. And what is the other one? Multiplication. Where do we start? In addition and subtraction. So we start from subtraction. So what is the opposite of subtraction? So we add 8, add 8. We're left with 20 equals 4 times y. So what is the opposite of multiplication? Division. Divide by 4, divide by 4. Therefore, get it? Therefore, 5 equals y. Let's plot it really quick. 0, dot, 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 5. There it is. And let's check it. This will be the last one that we plot and check so we can go a little bit faster. Check. We got 12 equals 4y minus 8. 12 equals 4 times 5 minus 8. 12 equals 20 minus 8. And 12 equals 12. Yes? That was a 2-step equation. One more of these. Yes? Last one, example 2 mega q. X over 5 minus 3 equals 7. See if you can do that one by yourself. Okay, Isaac, help me out with this one. Can we simplify the left side? How about the right side? Nope. All right, so what operations do you see over here? Division and subtraction. So where do we start? So what is the inverse? Add 3, add 3. X divided by 5 equals 10. What's my last step, Isaac? Multiplication, because it's the inverse of division. So we multiply times 5, multiply times 5. So therefore we end up with x equals 50. Hands if you got that. Okay. All right. 2-step. Now we're moving on to 3-step. Yeah, let's go. Example 3Q. Copy this. 4x plus 2 plus 2x. If it doesn't fit in the front, turn your paper over or get another one, that's fine. Equals to, give me a number. Okay, 20. No, 20. All right, here we go. Line down the equal sign. Question, can we simplify the left side? Yes. Now, this is where everything that we did before kicks in. Watch, if I was to cover this, does this look familiar? Remember what you need to do here. That is correct. Combine like terms, yes? So this one and this one become what? 6x, bring down the plus 2. And what did we have next to that? We had the equal sign and 20. Do we know what to do from there? Yeah, finish it off, please. All right, so what do we end up with? We multiplication and addition. We start with addition, subtract 2, subtract 2. We end up with 6x equals 18, and at the end divide by 6. Therefore, x equals 3. Okay, and do we got that? Okay. Let's do another one of these. Example 3 super q. 3 super q. Let's do 30 equals 6y plus 5 plus negative 1y. See if you can do this one by yourself. Copy that and go. Let's see what you get for this one, Julian. No, just the answer. What'd you get? Hands if you got 5 equals y. That is correct. Here goes this process. Can we simplify the right side? Yes. Combine 6y and negative 1y. That becomes what? 5y plus 5. Bring down the 30. Next. Where do we start? Subtract 5. Subtract 5. We end up with 25 equals 5y. And the last step? Divide by 5, divide by 5, and that's how we get 5 equals y. You got this, yes? Yeah. Crank it up a notch, yes? All right, another 3-step. Copy this one. Yes. Woo, let's go. Example 3. Let's label this one 3 Michael Jordan Q. 3 MJ Q. 2/3 R plus 3/4 equals 7/12. Just copy it. I'll go over this one. Now, I know some of you love working with fractions. But some of us might say, you know what, I'd rather not work with fractions. Let me show you not working with fractions. Writing utensils down, look up. To get rid of fractions, I need to look at the denominator and find a common denominator. What would be my common denominator? So I need to multiply the entire equation, just the numerators, times 12. 12 times 2, 24 over 3r. 12 times 3, 36 over 4. Notice that I didn't multiply the denominators. And 12 times 7, that's 84 over 12. Now, why do we do that? Because we get rid of the fraction. What is 24 divided by 3? 8r plus 9 equals 7. Look at this. You know how to do that. Copy that and finish it off, please. And this one, you're going to end up with a fraction, which is okay. So here, if we go down the line, subtract 9, we end up with 8r equals negative 2. And the last step, divide by 8. Therefore, r equals negative 2/8. And if we simplify that, that becomes what? Negative 1/4. Yes? So what is the critical step for these with fractions? Multiply times the common denominator on the numerator. Yes? Now, before we leave, last one. Don't copy this one. Just look at this one. Write your utensils down, look up. This one seems simple, but we have one fraction on the left side. We can't simplify unless we get rid of this one. Do we know what to do if it was looking like that? Yeah, right? So what do you think I'm going to do to get rid of this 3 if it's dividing? I would multiply times 3 to get rid of the 3. Multiply times 3, Check this out. I'm left with 2x plus 1 equals 21. Do you know how to solve this? Yeah, just remember when you get something with a fraction on one side, get rid of the denominator first and then do the rest. Your home plate, come get a play sheet over here. There is tutoring today. For those that are watching on the video, the home plate is right there. Those 10 problems. Good one, guys. If I don't see you in tutoring, see you guys tomorrow. Enjoy your home plate. Bye.